So let's suppose consider the one slice of a bread, okay, for using breakfast, or two slices. So let's start from it. Volume formulae, and according to volume formulae we know, because it's the change in volume, okay, one slice, or you can say that there are too many slices, but overall volume of a bread, a change in this from this point to this point, we can determine with the help of area, and in case of large piece we can say delta x. This is the volume. Why? This A basically length into width, and this will be the third size, or you can say its height whatsoever. Okay, this is the third. Area represents the two sides. Area represents two sides, and third side is delta x change, or it can be thickness or whatsoever height. Okay, so in case of limit, okay, this is the overall volume. We are talking that this is the overall volume or change. We want whatever the from point, this point, initial point to the this point, last point. Okay, this is our represent delta x change. So area is going for overall volume. If in case of limit, delta V transforms to dV. Overall area will be transformed to area of particular slice face, although it may be somewhere, if bread, okay, complete loaf of a bread is a uniform, or is usually not a constant shape, somehow homemade or even in a bakery, due to its cooking or baking process, its surface is not perfectly or exactly uniform. So of course its following area can be changed with respect to x, okay, along the position on the x-axis. So but however, and this change, okay, each piece are changed along the x-axis for limited portion, or for first slice. For this first slice will be transformed into dx. Therefore the net volume, total change in volume, that is somehow this one, will be transformed to this. If we want to determine the complete volume of this loaf, okay, complete this loaf, so it can be performed by applying integral on this one, integral on both sides of this equation. Then we will have integral and of course it will equal to because area is a function of x. Remember, here area is not a constant thing, it's a function of x, so we will consider it inside of integral. And otherwise we can also express in the according to Riemann integral I equal to 1 or n pieces, maybe 5 pieces, 10 pieces, whatsoever, and A is the index of the pieces, or you can say A sub I, area for the chain along the x-axis. Though this is representing the volume, overall volume, it's a case once we don't have exact shape of a bread, or we want to determine the complete area in a continuous fashion. But if we want to determine area of the bread with the help of summing up each slice, then definitely this is the total change. This is the area of n slices, or index for index somehow. So we are summing up all, and this is usually representing the discrete case. If you want to see this expression, you need to sum in a discrete fashion. Sum of the this Riemann sum will be used, but whereas we need to determine the continuous sum, okay, continuous information, then we are using the integral. Here you can see further the continuous distribution. For example, in this case, continuous integration is giving us the complete information. But here, with the help of sum, okay, this sum, we are following the discrete distribution, or this summation is a discrete, but in this case we are not getting the complete information. Some information can be missed. For example, this portion, this white color under the curve is a missing area, so we are not calculating, or we are not meaning this area because it's underneath the curve. So we are in a problem, we are shortage of exact area. So but for generalized case, yes, somehow we can use the summation sign according to Riemann integral, and we are considering the delta x overall change for whole all along the x-axis. But however, here we are slicing up into infinitesimal slightest possible rectangles. So very close, almost okay, close, and the thickness of each slice is representing with the dx, and we are sum up all the slices. So error, big error, this error, okay, this error cannot be noticed. This can be minimized. Similarly, if we are talking what is the important thing in this case, continuous distribution case, what is the meaning of partitioning area under the curve into n, or you can say that there are n rectangles, okay, or n rectangles such a way that n number of rectangles, or n rectangles should be infinite, too many rectangles. What is the theme of this? Let's see that why we need to partition area under the curve into infinite portion, infinite rectangles. It's very simple to understand the concept of area problem. See, we want to determine area under the curve. Here it is almost look like some kind of some partial segment, or you can say sector of a circle. If we see the here a little bit in a clear sense, we see that this portion, okay, it's very close. Or if we want to area under this curve, of course this portion or this, okay, some big portion can be ignored. So this ignored area is kind of an error for us in final sum. To overcome this error, we are partitioning area under the curve into slightest possible rectangles, and these slightest possible rectangles give us some kind of approximation. There are 3 sides of this triangle. We can easily calculate it. 4 sides, it's kind of a square. We can easily calculate it. 5 sides, of course, we can easily calculate it. A1, A2, A3. We know the formula of a triangle. Sum up all the A1 to A3. Okay. Similarly, here we want to divide it into the 4 triangles. So A1, A2, A3, A4. So it is possible to determine the area of this polygon, 6-sided polygon, 4, yeah, okay, n equal to 4. In case of 7, we can also determine slicing up this area of 7-sided polygon into various rectangles. Similarly, for 8-sided, we can get a number of rectangles for it. Okay. In case of 7-sided polygon, we can draw few triangles for it. Here again, for this polygon, which is composing of 8 sides, we can consider the various triangles for its calculation. For 9-sided polygon, again we can partition into various triangles. Similarly, like go, and there are infinite, too many. Okay, once too many rectangles here. So what will the case? Area is equal to an, and such that n approaches to infinity. Number of n represents the number of sides. Number of sides will become infinite. Once the number of sides will become infinite, so it becomes a circle. And we know the pi equal to this ratio, okay, and if it's the unit circle, then a pi r square, a answer is pi. Remember this, it's now simple to us. With the help of 1s, n approaches to infinite, and it is almost giving us the exact area. If we have radius is 2, then of course it's the 4 pi. Therefore, it is considered that n approaches to infinite give us the overall information in a bestest possible way. Until that, we studied about area under the curve. Today we will study area between the curve. Area between the curves. Example of this, if there are two cars A and B that start side by side and move along the same road. If we are considering a racing track, okay, two cars are competing with one another on some racing track side by side. So what does the area between the curve represent? Of course, for example, this is the here in case of graph, so it's the vertical axis represent velocity, okay, mile per hour, and the horizontal component represent the time in second. So this above graph is representing for car 1, the lower graph is representing the car B. So the gap between, actually we want to differentiate the you can see that velocity of our two cars in some competition. For this purpose we use to determine area between the curves. There are huge number of applications, but for our interest simplicity, I am considering the racing track for two cars. So there are two curves, of course, for changing of speed with respect to time. Let's see an example. Notice that due to driver experience, car powers and certain other parameters, both the cars will perform in a different way. Of course, due to these reasons, car 1, both the cars speed will behave differently. Therefore, we are getting the difference. Car A is ahead to the car B. So this is telling that it is the car A at unit time 16 second, car A is 29 feet ahead of the car B. At unit second 12, car A is 28 feet ahead of a car B. At unit time 8 second, car A is ahead of the 23 feet with respect to car B. So we need to determine the total distance covered by car A and car B. Of course, in terms of a gap, or we need to determine. Okay, in a nutshell, we can say how much car A is ahead of car B. If we want to determine the discrete interval according to this given data, it can be measured in area for unit interval, or starting from 1 to 4. We know this is area and this is the time. How many intervals of time? Each interval is representing the 4 seconds. So this will equal to 4 seconds, and there are four possibilities of areas or gap between two cars. So we will write 4 here. So 1 to 4. The first is 13 plus 23 plus 28 plus 29, and here we will multiply with 4. So sum up, that's the 27. This is a discrete, you can say, information with the help of Riemann integral. However, because during the competition each fraction of second is having huge importance, so we need to apply integral area with the help of continuous fraction. Of course, range is, that is definite integral. Range is given from 0 to 16 second. Time, initial time is 0 second. The final time is 16 second. And of course, the velocity of car A will be Okay, it's you can say upper curve. It's the upper curve. Here, see velocity of car A is representing upper curve. So we will write it at first place, subtracted with velocity of car B. And what we do here, we need to slice up time interval into slightest possible fraction of dt, as this big change of the 4 second will be transformed to teeny tiny second or nano or macro second with the help of computing formulae. You know the velocity of car, from this changing with respect to from 0 to 16 seconds. So here we need to integrate both the velocity at position A and B, and we need to substitute the value, and we will get a result. Integral is much correct, much better as the area measured by summation sign. So this one, if we want to determine the accurate area or accurate gap between car A and car B, integral is giving a perfect, or you can say most reliable result. This summation is can be used for general purpose, or you can say general information, not the exact information. This is almost near to exact one. Integral gives the result near to exact one. So we can see further. This is the situation. For example, this curve g of x is representing the velocity of car A. Okay. Similarly, this one is representing the velocity of car B. So S2 is representing how much car A is ahead of a car B. This is the theme that why we need to use, why we need to determine area between two curves. Remember, if the speed of car B is higher than the speed of car A, of course it will be written at first place. If the speed of car A is higher than the speed of car B are almost equal, so speed of this car A will be written at first place, or you can say the total change or gap of absolute values. Okay, area always measured in a positive quantity. So this is the, you can say that the complete formulae for determining area between the two curves. That is the absolute. Here it does not matter g of x is representing at first place or f of x is representing at first place, and of course it is much better if it has considered the definite integral.